Hello everyone. Today we're going to discuss relational database management systems. Before we actually do that, I would like to introduce myself. So my name is Shoaib Ahmed Abbasi. Um, I am currently working for Transport for London as a database and data warehouse developer. I'm in the industry from past 6.5 years now, and I've been working on developing databases and data warehouses. Um, the aim of today's presentation is to um, briefly discuss the history of databases, where they have actually come from, and then look at the types of relational databases. It's quite important to actually know the different types of relational databases because when generally people think about databases, they think about SQL Server or MySQL. Um, but then there is a higher level of differentiation between the main types of relational databases, so it's quite important to actually know that. And then we're going to look at some category of databases, then we're going to look at the vendors that are out there at the moment selling database relational database software. Then we're going to look at something called normalization, which is quite important to actually know. And then we're going to look at the different types of normal forms or types of normalization that are there, and then we will discuss disadvantages of normalization, um, and towards the end, I would like you to basically introduce something called NoSQL, or difference between SQL and NoSQL. I'm quite sure that most of you are familiar with SQL, um, but there is something else out there that's actually called NoSQL, and it's getting quite popular. And it's important to differentiate between the two. And finally, we will have a demo where we will look at the normalization and its disadvantages. Um, so starting from the brief history, um, so flat files were actually used, back in the days, and these flat files were actually called data store or database. So if you have data in a flat file, it's absolutely fine to call that as a database. So data stored in a file is a database, and that's how data was actually stored back in the days. Um, but storing data in flat files, has its disadvantages. Um, for example, you can have data duplication, also called data redundancy, within your files, and you wouldn't, necessarily know or stop that from actually happening. There was also a problem of, defining the relationship between the entities in your data. So referential integrity was, the absence of referential integrity was, was a major disadvantage, as well as the data redundancy. Um, and also, there wasn't any standard method to actually retrieve data. So, for instance, if there were two banks, bank A and bank B, bank A was retrieving data using, his own custom retrieval method, and bank B was using its own custom retrieval method. And what I mean by custom retrieval method is, obviously you have data stored in your flat file. You want to read those flat files, read your data, read your transactions, and to do that there wasn't any standard mechanism to do so. So mainly there were C programs or COBOL programs, written specifically for specific companies to actually do that, and that was quite a problem, because there wasn't any standard method of reading files or reading data, stored data. And then in 1970s, a person at IBM basically solved these problems and introduced a concept of relational database. Um, and relational databases, solved these problems what what I mentioned earlier, such as data redundancy, the absence of relationship between the data, and the standard mechanism of retrieving data. And because it solved these problems, it quickly became industry standard. So more and more companies were, started adapting relational databases. Um, so today, as we know, we have two main types of databases. We have a row-oriented databases, we have column-oriented databases, and this is looking at from probably 50,000 feet above the ground. So if you're looking at 50,000 feet above the ground, at the types of relational databases you see two. So you see row-oriented and you see column-oriented, and as the name suggests, row-oriented databases basically store data on the disk in a row format, whereas column-oriented databases store data on the disk in a column format. Um, Categories of databases, there are many different categories of databases. This lecture is all about relational databases, but it's very useful to actually know that there are other databases out there. So for example, there's an object-oriented databases. Object-oriented databases are very very good at specifying more complex relationships. Relational databases don't really excel at specifying extremely complex data relationships. In object-oriented databases you have that flexibility to do so. Then you have document-oriented databases, mainly used for storing, your documents such as XML files or any type of flat file or a Word document. Um, and then you have very interesting graph databases. Graph databases have become quite popular because they solve a specific type of problem. Um, the companies that I know are using graph databases are, Facebook and LinkedIn. LinkedIn is a professional network, where you basically update your employment history, and based on that, you're basically it gives you a suggestion, saying if you know this person, then you may know this person as well. And all of these connections, how it actually knows, just by looking at your employer, that you might know the person, or you might have worked with the person in that company, is using the graph databases. And those relationships are more complex than the relationships that we specify in relational databases. One of the things that I want you to understand is, um, all of these databases they solve different types of problems. So it's quite um, um, difficult to actually compare them, because they all solve different types of problems basically. So it's quite difficult to say, or probably not the um, right way to actually differentiate these based on their own functionality. So whether relational databases is better than a graph databases, it depends what type of problem that you're trying to solve. But the thing I want you to understand is that all of these type of databases solve different types of problems. Graph databases are very interesting, and they're able to actually solve problems, what we actually looked at LinkedIn and Facebook. If you know a friend, it suggests that you might know the other person as well. um, Spatial databases are all about specifying the or using the geographical locations, and storing geographical locations, and retrieving geographical locations. Um, some of the relational databases I know have this functionality as well. For example, Microsoft SQL Server has introduced some special functionality. I think from 2008 version onwards. But really, truly, spatial databases are out there specifically to solve geographical reporting or geographical data storage problems. So they excel more towards storing geographical data or retrieving geographical data. They store latitude and longitude, and then you can query or retrieve latitude and longitude. And you have many functionalities within there to actually look at yeah, geography. Um, and then we have key value databases. Key value databases are getting quite popular. They are very lightweight. They're not as heavy as relational databases, and they're mainly used for storing unstructured data. So now looking at databases, relational database vendors. So there's two main school of thought, if you like. So there's an open source community, and then there is commercial or not open source solutions out there. Open source is not always free. Open source just means that you are able to actually look at the source code. So how, for example, if you use MySQL, you can go to the website, you can actually download the actual program code, written in C++ or Java. So you can actually see how MySQL database, the source code for MySQL database, and that's what open source means. A non-open source means that you're not able to actually look at the program code or source code. So for example, Microsoft won't allow you to look at the source code for SQL Server. So the two main open source databases that are out there, so we have MySQL, very, very popular. A lot of companies are using it. Amazon is actually using MySQL. They have heavily customized it, but they're using MySQL. And then PostgreSQL. PostgreSQL is also quite popular. Um, the company I was working with in 2013 was using Postgres transactional database. And the advantages of using open source is you can customize these databases basically the way you want to, and you have that flexibility of actually doing it. And there's a bigger community out there. If you have any issues, or you're struggling to basically do your development or configuration, then I think MySQL and Postgres has a very large community out there to actually help you out with solve problems. And also it's free, so you don't pay for any licenses. So that's the main advantages of using MySQL and Postgres SQL. Obviously they have their downsides as well, they have their disadvantages as well. For example, the source code is not managed. It's managed by the community, but it's not managed by a company. So you're really on your own. If you have any issues or have any problems, there's a community out there, you can post your questions, but there's no legal binding or agreements basically. And also, if there are any bugs, then bugs may or may not get fixed very, very quickly. So it depends. Sometimes they do get fixed very quickly because they get reported very quickly because more people are using it and it's free. But sometimes they don't get fixed quite quickly. So you may have to wait until the new version of MySQL or PostgreSQL is actually released. And then looking at some non-open source, sort of enterprise commercial database software. So Oracle is actually leading relational database vendors. Oracle has many different relational database products. Basically, it's actually beyond the scope of this presentation to actually discuss the each of the products that these vendors have. So I am just going to give you basically the name of these vendors that are actually out there. Might be useful to actually know, because sometimes when you're new to relational database management systems, you think that there might be one or two vendors out there, but in fact there are many. So you have Oracle, you have Microsoft, and Microsoft products called SQL Server. Then you have SAP. SAP has its own database products. IBM has its familiar and very famous DB2 database, and then you have Teradata, and then you have Ingress. Oracle is actually leading, as I said earlier, and then it's SAP, Microsoft, IBM is quite popular as well. Um, so let's now discuss about discuss about normalization. Um, so remember I mentioned earlier about data was stored in a flat files, and there was no structure to the data, there was no relationship defined in that data, and data had duplications, redundancy. So relational databases solve these problems, and they solve these problems by applying the concept of normalization. Now the process, so normalization is actually a process of reorganizing your data in a database, um, so that it solves those two problems that we actually looked at. The data redundancy and data dependencies. We will have a demo, and in that demo I will basically show you how you actually normalize, and the problem that it actually solves. And then I believe it will be um, uh, more clear to you, what exactly normalization is. But as discussed earlier, it solves these two problems, the problem of data dependencies and the problem of data redundancy. Redundancy means, data duplication. So if you have customers placing orders, and customers have a customer ID, if you don't have normalization applied, then you will have customer ID repeated for every single line item of your order. And that's data duplication. Data redundancy. Normalization solves that problem. We will look at in the demo. Um, so normalization has its types, its forms. It depends how deep you want to go. It's up to you. Industry standard is going down to third level, which is third normal form. You have the first normal form, you have second normal form, and then you have third normal form. All of these normal forms basically solve problems of data redundancy and data dependency. The first normal form is basically about actually solving the problem of data redundancy. Just so you separate your entities out, and that's how you basically overcome the problem of data redundancy. And then you have second normal form, and then you have third normal form. Um, what I want you to know is there are other forms as well. So there's void core normal form, there's fourth normal form, there's fifth normal form. But the industry, all only uses third normal form. I have not seen any implementation myself. Where companies have actually gone beyond third normal form. Um, and the reason for that is, third normal form solves your problems. If you have um, problems beyond that you can probably apply fourth normal and fifth normal forms. But you also have to understand that normalization has its own disadvantages. So if you go beyond third normal form, you have advantages, but you have disadvantages as well. Like even if you're applying first normal form, there is an advantage. Obviously you are getting rid of your duplications, and you're introducing relationships, but it also brings disadvantages. And the main disadvantage is, because you separate your entities out, now you have to join these entities if you want any meaningful insight. So for example, um, you if you want to know the customers who bought a certain product on a certain date in a certain city, to be honest, which is quite it's a quite frequent question that actually marketing or sales department want to know. So they want to know the customers who basically bought a certain product on a certain date in a certain city, so that they might give them a promotion, or maybe the customer is refunding their item, and they need to know whether they have actually bought this item or not. So it's a very frequent query. So if you have applied normalization and you want to answer this question, basically then you would need to join all the entities, and because you need to join all the entities, it actually affects your query performance. So more joins you have in your database, longer it will take for the query to retrieve data. Now you can optimize that query. There are ways of optimizing your query, but it's really beyond the scope of this lecture to actually discuss about how you can improve query performance. But even if you do improve query performance, if you have joins, the more joins you have, so the rule of the thumb is more joins you have, slower your query will be. So it will take longer to answer your questions basically. um, So SQL versus no SQL. So what exactly is SQL? So SQL. So remember we discussed about back in the days flat files. Banks were actually writing their own programs to basically read from the files or retrieve data from the files, and these programs were actually different between organizations. So Bank A had to retrieve customer information. They had to write their own, COBOL or C program to actually do so. And but structured query language has become a standard now with databases. So it's a language that you actually use to retrieve data from a database, and it's industry standard. So for example, now organizations using the standard language to actually retrieve data from the database, and it's called SQL, and it stands for structured query language. I am quite confident that you definitely have heard of SQL. It's quite popular, and it's very easy to write or to learn as well. But there's something else with SQL that's becoming quite popular now, and it's called NoSQL. Um, a lot of people think that NoSQL is, that you have no SQL, and it actually means the opposite. So it means not only SQL, which means that you have the functionality of the SQL, but you also have something extra, if you like. So basically, you are able to use SQL to retrieve data from your data stores, but um, you can also customize and basically retrieve data from non-relational databases. It's mainly used for retrieving data from non-relational databases. It's not something that you use in a relational databases. It can be used to retrieve data from non-relational. I think some vendors have this functionality. For example, Microsoft's Parallel Data Warehouse, also called PDW software, has both functionalities, so SQL and NoSQL. But generally, you would see that NoSQL is only used for retrieving data from non-relational databases, and um, there are different vendors out there that they actually sell their own products, and they allow you to retrieve data from non-relational data sources. Um, the syntax can be quite similar to SQL. All the clauses of SQL can be, or the syntax can be very similar, but it does not mean that it's actually SQL. It's so I just wanted you to basically know that there is something else out there that's called NoSQL, and it's actually used to retrieve data from non-relational databases. Um, and non-relational databases are solve different types of problems. Relational, as we looked at, relational databases solve problems when it comes to storing or retrieving transactional data. Non-relational databases solve problems of storing and retrieving data that has no structure. So to give you a quick example of the data without any structure is a tweet. So if you use a Twitter and you actually tweet, it basically has no structure. You can write anything, you can post anything, you can just write a text message on a Twitter, or you can have you can have a photos share, for example, on Facebook. There's no structure to that data, whereas in a relational database, you can't actually store data unless you define a structure. So basically you must know what a customer is. So you might have customer ID, customer name, his address. But non-relational databases basically store the data that's not structured, and there is more unstructured data out there than there is structured data. um, so, guys, thank you very much for listening. I hope it was useful, and we will see you in the demo. Thank you.